So today I'm going to upload the first video of a series that I want to film about vacuum tube TV troubleshooting. I started repairing TVs quite a few years ago, and when I started there was almost no information available, only tiny bits of information scattered here and there. The forums don't seem to help you very much, because when you ask for advice, people just tell you you need to buy an oscilloscope, you need to buy this, you need to read this book, you need to read that. And when you put a schematic and you upload a schematic and you put a new thread on a forum and you ask people for advice on a certain symptom, they just stop responding. It's understandable. People don't want to waste a lot of time. They don't have the TV with them. Sometimes they don't have the knowledge to really help you. They just want to give you advice that they read somewhere else, and so you're pretty much on your own. Being on my own and doing some dumb stuff, repairing some sets and destroying others, I have learned quite a few stuff that can be useful if you are coming from radio repair and you want to start repairing vacuum tube TVs. I'm pretty sure you will find something useful in this series of videos. So right here in front of me there's a hybrid television. It has 1, 2, 3, 4, 5, 6 vacuum tubes, and the rest is all transistors, solid state. And this is a, let me see if I can show you, it's a Blaupunkt set, and I don't have a schematic for this TV. I don't have a schematic for any of my Blaupunkt TVs because I don't know what happened. There seems to be no schematics available for this brand, at least the ones that I have. So troubleshooting is extremely difficult. This one is already kind of working. I have one over there. This one is restored already, and I have quite a few working equipment. Anyway, so first thing that I want to show you, and it's one of the most common faults, is to diagnose a hard short. And what is a hard short? I have here on the floor a schematic for a different TV, but it's pretty much the same. So let me see if I can do this. I'm holding the cell phone with one hand. So mains comes in right here, then it goes to a fuse to ground. It's got here some decoupling, some across the line capacitors, a small choke. This is a dropping resistor. We got the rectifier, half-wave rectifier. Then we have another fuse, some smoothing capacitors, some resistors, and we have the several different voltages available for the B+. We got 260, 240, blah 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 blah. So typically these points right here, +2, +3, +4, these normally go to the plates of several tubes. So let me see if I can show you. We got here +4 goes to a resistor, then it goes through this coil up here, and it goes to the plate of this IF tube. So really nothing to short here. And we got here another one, +3 goes down to the plate of this tube. This is the sink separator, so nothing to short there either. Assuming the tubes are cold and there is no conductivity, conduction, whatever you call that in English. So what am I trying to say here? A hard short is when you put the plug in the socket and the fuse immediately blows. That is a hard short. The tubes are cold, the filaments are not lit yet, there's no conduction in the tubes, there's nothing happening in the circuit. So it's a short somewhere in the power supply section, right here. This is a series string TV It has no power transformer, and what that means is we have mains voltage going to the heaters of the tubes. They're all in series, and so we don't need a power transformer for the TV to operate. And the other thing is that mains goes directly to the chassis. One side of the mains is always connected to chassis. So I'm not going to go into detail about safety because you probably already familiar with that. So we had a hard short on this TV, and unfortunately I have already diagnosed it and I didn't film it, but I'm going to show you the process of thought. So as soon as we powered this thing up, the fuse blown. I have a makeshift fuse installed because I don't want to go to the electronics store just to purchase a fuse. You should never do this. This is dangerous for the TV, dangerous for you. Don't do this. Anyways, the set is already working, and I'm going to show you how did I got to this point. So we have a hard short, so from here forward there's pretty much hardly anything that can short because there is no conductivity in the tubes. Transistors could be a shorted transistor, but right here all of our high current stuff is vacuum tubes. Vertical output is vacuum tubes, horizontal output is vacuum tubes. The only transistors we have on this TV are a raster stabilization transistor, and we got here a transistor in the IF, so if they were shorted they would probably blow up and the fuse would be intact. So first thing I did was lift the leg of this diode off the circuit and try again, see if the short is still there. Why? Because it will isolate all of the heaters. Let's imagine that this capacitor is shorted. If this capacitor would be shorted, this would cause a hard short. So I lifted up the leg of this diode, and you can see it there. There is it, that diode, and the short was still present. Next, I lifted off this capacitor and this capacitor. These are across the line capacitors. This should be replaced on any TV set. These were not the culprit, these were fine. So what can be shorted? This diode cannot cause a hard short. Even if it shorts, it will not cause, because it's not a bridge rectifier, it's just half-wave rectification. So if it's shorted, it will just feed AC instead of DC and the TV will not work. So we got here a filter cap that can cause the problem. If it's shorted, it will cause the fuse to blow. We got another one right there, another one there, and another one there. Any of these can cause a hard short. We got what do you call this? Double pole power switch. I don't know how to call that in English, but basically both neutral and phase both enter the switch. So if the switch is shorted inside, it will cause a short, but it will not blow the fuse because it's before the fuse. So although this can cause a short and can cause your house breaker to trip, this is not the cause for our short because we are blowing this fuse right here. This fuse, 2 amps fuse, is blowing. So I will turn my attention to the smoothing caps. And where are them? They are inside this can right here. And we can already see here one of the dropping resistors got quite hot, quite smoky. Probably I had a feeling that it was faulty capacitors inside this. We're going to take a look at the TV, which would be the first thing to do before all this diagnostic. We should take a look at the TV, look for any signs of burning components, get familiar with the circuit, etc. So what we have here, we got here two transformers, a small one and another one a bit larger. None of these transformers is a power transformer, they don't have the size for that. So just by looking at this we can see it's a series string TV. Normally we have an audio output transformer and a vertical output transformer. So taking a look at here, we have the speaker, and the speaker cable usually goes to the audio output transformer, which is this guy right here. This by exclusion, we say here parts exclusion. I don't know if that's a valid expression in English, but this would be the vertical output transformer. We got here a tube which is a PL95. I don't know what that is for. We got here another one. It's a PCL85. PCL85 is probably the vertical output tube. This, I don't know, maybe an audio output or something. We got here PCF 805, and it's next to the horizontal section. So this is probably I'm sure this is the horizontal oscillator, because we have here the horizontal frequency coil. This coil you adjust this coil to adjust the horizontal frequency, and on later videos I will show you what that is and what that does. So I don't see here any signs of burning stuff, damaged stuff. This capacitor is cracked, but it's just the outer label that is cracked. The actual capacitor is good. Here on my hand is a shield for that IF. This is the video detector and the video detector diode and a bunch of coils. This had an IF problem, and I have been diagnosing it, and I have this off, but this will go in there together with this cardboard thing. Normally we have some sort of shield, can, or whatever you want to call it, and inside that we have the flyback transformer right here, responsible for the high voltage into the anode of the CRT. We have here horizontal output tube, which is always this fat guy right here. This is the damper. You can see here it's a PY88, the damper tube, and the high voltage rectifier. The high voltage rectifier always has this shielded thing on top, and it goes to this coil on the flyback on all TV sets virtually. This red capacitor is the booster filter or booster reservoir, and it's always good practice to replace this, because on most German TVs it always shorts and damages this damper tube. Here we have the yoke, and what's this? I see a shielded cable coming up onto this little board. And what does that tell me? When we have the video amplifier on the board, the video signal is already amplified, and it goes onto the CRT by a normal wire. It's usually a yellow wire, sometimes gray. But on this case I see a shielded cable coming up, which means we have probably a solid state video amplifier on this board. Let's see. Some picking coils. There it is. I don't know if I can show it better. I don't know if you can see inside that heatsink thing, there is a germanium transistor. It's a BF179. That's our video amplifier transistor. So we have solid state video amplification, and the video signal comes in through this shielded cable. Because it's low amplitude signal, it has to come up on a shielded cable. How do I know that this is a shielded cable? Well, it's got two conductors, and one of these conductors is a mesh that's wrapped around the inside conductor, and that mesh is connected to ground, and it prevents interference to enter our video signal. So right here we have our power cord coming in right here to the power switch. After the power switch, power comes in through this connector. We got here our dangerous makeshift fuse and our main filter cap, and that's pretty much it. Where you see a lot of cans and coils like this is the IF section. This is probably the video IF. Then we have a video detector, and this is probably the audio IF. We got here a bunch of transistors, so the IF is solid state. We got one there, one over there, other over there, and a couple more here. We got one here, one there. This is the tuner. The tuner is also solid state. I don't see any tubes on it. And now that we are familiar with the circuit, now that we know there's nothing burnt or shorted or melted, at least visibly, we can proceed.